Have you ever wondered just how much power humanity actually has? No, I'm not talking about atomic bombs or deep space rockets. I'm talking about a biological force. What if, right now, every single one of the 8 billion people on Earth coordinated to gather in New Jersey and perform the loudest, smelliest, and most dangerous stunt in history? Just imagining it makes me sick. Today, we're going to find out. If we all farted at the exact same time, would it push the Earth out of its orbit, or would we literally set the atmosphere on fire? First of all, for this stinky experiment, we're going to need some space. Let's assume every person needs 1 square meter of personal space, so no one bumps into each other during the operation. That means we need a total area of 8,000 square kilometers. Now let's get into the dirty numbers. Every human releases about 50 milliliters of gas in a single go. 8 billion times 50 milliliters, that is 400 million liters of gas. 99% of that massive cloud consists of odorless gases like hydrogen, oxygen, carbon dioxide, nitrogen, and methane. But that final 1%? That's hydrogen sulfide, the direct culprit behind that foul stench and the silent killer of this episode. The moment the operation is triggered, 4 million liters of hydrogen sulfide are unleashed. Instantly, the smell of rotten eggs engulfs the entire state. But first, let's do the math on the concentration. If 8 million people stand in a perfect square with 1 meter of personal space, each side of that square would stretch to 89 kilometers. Now, if we assume this human cloud rises to a height of just 2 meters, the total volume of occupied space hits 16 billion cubic meters. Out of that, hydrogen sulfide accounts for 4,000 cubic meters. The result? A localized concentration of 0.25 ppm. To put that into perspective, the human nose can detect this gas at a mere 0.00047 ppm. That's the point where you start looking at the person next to you with suspicion. But here, we're dealing with a concentration 530 times higher. At 0.25 ppm, 8 billion people are hit simultaneously with a stench so foul it triggers mass vomiting. Just imagine 8 billion people throwing up at the exact same time. That's a biological crisis New Jersey never saw coming. And it gets worse. The moment this gas hits the moisture in your eyes and throat, it reacts. We're talking about 8 billion people suffering from severe eye irritation, runny noses, and dry, hacking coughs. At this concentration, the gas itself might not kill you, but the absolute panic will. When 8 billion people can't see and can't breathe, they run. And the real killer, the crowd crush, takes over. But the true nightmare happens in the center of the mass. Deep in the heart of the mass, where the wind can't reach, and because this gas is denser than air, it stays low to the ground. There, the concentration can spike to 20 or even 50 ppm. This is enough to paralyze your olfactory nerves. People in the center will think the smell has vanished after just 3 seconds, but in reality, their sense of smell has simply been destroyed. 10 seconds later, they're dead before they even realize what's happening. On top of that, because of the reaction between sulfur and copper, charging ports on your phones would likely turn black and fail. But you know what? Let's just forget about that 1% of hydrogen sulfide and its effects for a second. Let's assume everyone is wearing advanced air-purifying masks to neutralize the poison. Imagine someone in the middle of the crowd pulls out a lighter just to test something. And boom! A massive explosion occurs. Wait, no, that's completely wrong. First of all, only about 1/3 of our 8 billion strong population actually has the gut bacteria that produce methane, so that Michael Bay explosion you're imagining, it's not quite that simple. While a huge chunk of those 400 million liters consists of methane and hydrogen, flammability requires a very specific range. It can't be too concentrated, like in the middle of the crowd, and it can't be too diluted, like at the very edges. Secondly, according to stoichiometry, to burn 2 liters of hydrogen, we need 1 liter of oxygen, and to burn 1 liter of methane, we need 2 liters of oxygen. The only positive thing here is that burning hydrogen actually produces a bit of water vapor. So that lighter would have to be flicked at the edges of the crowd where the gas has mixed with enough oxygen to hit that perfect flammability sweet spot. The moment that happens, since these gases are lighter than air, they tend to spread upward and outward. The flame moves horizontally across the heads of the crowd at an incredible speed. And as you probably know, when this massive volume of gas burns all at once, it consumes all the oxygen in the environment, creating a temporary vacuum. Fresh, cold air from the surroundings is sucked toward the center with terrifying speed, creating a firestorm. This feeding frenzy brings in even more oxygen, making the fire even more ferocious. So much oxygen is consumed that even if people don't die from the heat, they will suffocate from the lack of air. The final result? In the blink of an eye, New Jersey transforms from a smelly wasteland into a colossal furnace that incinerates everything in its path. So, in either scenario, the end result is terrifying: death. Whether it's from the crowd crush and suffocation after the initial stench, or the incinerating flames of a hydrogen firestorm. We have effectively turned New Jersey into a giant killing field with no way out unless, of course, a massive gale blows in from the Atlantic to sweep both the deadly gas and the raging flames out to sea.